We're going to be evaluating algebraic expressions. And what it means to evaluate is to find the value of that expression or to find what that expression is equal to. So as you see, what we're going to do for this is first, we're going to substitute the given values for the variables. And then second, we're going to evaluate by following the order of operations. So we have this first example here. It says evaluate 3a squared minus b plus c cubed when a is 1, b is 4, and c is 3. I'm going to go ahead and rewrite this expression. And I'm going to substitute the values in. Now what I like to do is I like to put parentheses wherever there's a variable to start with. That way I don't miss anything. And so for A, we're going to put in 1. For B, we're going to put in 4. And for C, we're going to put in 3. And now what I have is just a numeric expression, and I can go ahead and evaluate this using the order of operations. So we'll start with exponents. 3 squared is just 1. 1 squared is just 1. This is just minus 4, so I don't really need the parentheses. And then plus 3 cubed. Well, 3 cubed is 3 times 3 times 3, which is 27. Now I have this 3 times 1 here. 3 times 1 is obviously 1. Minus 4 plus 27. What I like to do here is think I'm going to add these positives first. So that's 30 minus 4. And 30 minus 4 is 26. And so the first part is the only new part because we've worked with the order of operations. So we're just plugging in or substituting the given values for the variables. We're putting that into our expression. The next one is similar. This is x squared y z squared. And again, I'm going to put parentheses where the variables are. Now this helps because some people get confused about this y right here. Does the squared go to the z or to the y also? And it just goes to the z, and so putting these parentheses here will hopefully help you realize that. So we're going to put negative 1/2 in for x. In for y, we're going to put negative 2. And for z, we're going to put 1/4. And now we're just going to use the order of operations. So we'll start with exponents. We do start with parentheses, but there's nothing we can simplify inside the parentheses. So we're just going to leave it as negative 1/2, negative 2, and 1/4. And then we do the exponents. So negative 1/2 squared is negative times a negative, so that's positive. And 1/2 times 1/2 is 1/4. That's going to be multiplied by negative 2. And then 1/4 squared is 1/4 times 1/4, which is 1/16. Now we just have multiplication left. We can remember that this is the same as negative 2 over 1. That way we have they all have numerators and denominators. We can do a little bit of simplifying. So negative 2, or 2 goes into this negative 1 time. 2 goes into 4 2 times. Multiplying across, we have 1 times negative 1 times 1, which is negative 1, over, and 2 times 1 times 16 is 32. So we have negative 1 over 32, which we also could think a negative divided by a positive is negative, so we could put the negative out front, and we have negative 1 over 32. So evaluating expressions is just substituting the given value in for the variable and then figuring it out using the order of operations. We use this idea of evaluating expressions when you use formulas. Formulas are very helpful because we can find formulas to represent different relationships. And so we have that formula and we don't have to figure out the different relationship each time. So a formula is an equation that expresses the relationship between related quantities. Here's a couple formulas that they are giving us. So this says P equals 0.0433 H, where P is pressure and H is depth in water. So this is talking about the pressure that is felt when something's submersed in water. And we all have probably felt this before, because when you go deeper underwater, you start feeling the pressure specifically on your ears. So that's what that's saying, as as you get deeper, the depth in the water, then the pressure is going to increase. The next one we're probably a little more familiar with, Fahrenheit, or F, is 9/5 C, which is the temperature in Celsius, plus 32. And so that formula there is saying if you have something in Celsius and you want it in Fahrenheit, you take the Celsius, multiply it times 9/5. Once you get that, you add 32. So those are two examples of formulas. We'll look at a couple others later. And so formulas are mathematical sentences that are used extensively in many professions. Many different professions have formulas that they use. They plug in the values to help them figure out a specific answer. So using formulas, when coming across a problem, you obviously want to use the correct formula. And then you're going to do what you did before. You're going to substitute the given values for the variables in the formula, and then figure out what that expression is equal to. Here's some words that you'll see in application or word problems. And so when you see these, make sure you know which symbol to use. So this is the top one, is the one we'll use the most, is equals, which we'll see is, or another tense of that, was or were, or just the word equals, and that's pretty obvious. Is not equal to, you see there, is approximately equal to, that's an equal sign more made out of squiggly lines rather than straight segments to make the equals. We talked about a few of these other things before that deal with sets. So we have is a subset, is an element of, is not an element of. We haven't got to our inequalities yet, but we'll get to those later. You've seen them before in previous courses, but we have greater than, less than, and then the ones with the little lines underneath, is at least, which we think or read that a lot of times, greater than or equal to. So at least, so the very lowest, so it has to be greater than that or equal to it. And this one we think of less than or equal to. So this last slide, we're going to look at a few more formulas dealing with geometry, dealing with perimeter and area. And then we're going to do a couple examples. So for a rectangle perimeter, if you think of a rectangle, you might have, this is the length and this is the width. Well, in a rectangle, these two are the same, and those are the same. So you really have L plus W plus W. But when you have L plus L, that's 2L plus 2W. The area, if you remember from before, is just length times width. I think you probably would have seen that before. A square really is a type of rectangle, but a square, all the sides are the same length. So we might put S for all of those, and if we add all those up, we get S plus S plus S plus S. Well, that's 4S for the perimeter. And for the area, we do S times S, which is just S squared. For a circle, we want to find the perimeter, which is called the circumference, and what we need is the radius. The radius is the length from the center to a point on the circle. So that's supposed to be an R there. And so for perimeter or circumference, it's known as in a circle, it is 2 times pi times the radius. Realizing that the radius is half the diameter, if you ever get to something like that. And then the area of a circle is pi times r squared. And then a triangle, to find the perimeter, we just add up the three sides, so a plus b plus c. And for area, I'm going to let this b also represent the base. We take 1/2 the base times the height. Another way to look at that one is base times height and then divide it by 2. It might be easier. So in these two examples, we're going to be using these formulas we just looked at. So find the perimeter of a rectangle whose length is 8 centimeters and whose width is 3 centimeters. It might help to draw a quick sketch. The length is 8 and the width is 3. So we know that the perimeter, so I'll put P equals, perimeter equals, and if we look up here, it's going to be 2 times L plus 2 times W. So I'm choosing the correct formula, and then I'm going to plug in the values for that formula. So the length here is 8 centimeters plus 2 times the width, which is 3 centimeters. And then we do our order of operations. We have to multiply first. So we have 16 centimeters plus 2 times 3 is 6 centimeters. Add those together, we get a total of 22 centimeters for the perimeter. The second example, find the area of a circle with a radius of 9 feet. So this is asking for area. So we want to look, here's a circle, we want area of a circle, which is pi r squared. So we can have area equals pi times r squared. And we know that pi, hopefully we know pi is about equal to 3.14, and then times the radius squared. We know the radius is 9. And so we have 3.14, 9 squared is 81. I should have put the units in there. 9 feet. So when we do 9 feet times 9 feet, we have 81 feet. 81 feet squared. And so we need to multiply that out. So we'll do that work up here. We got 3.14 times 81. And so we get 254.34 feet squared. And so that's using formulas. So in this lesson, we looked at simplifying or evaluating algebraic expressions. So they had variables and numbers in there. And then using that concept, we were able to use formulas where we chose the right formula, plugged in the values, and then we were able to find what we were